Continue with curve sketching and the applications of differentiation. Okay, so we look at the questions in exercise 12.12.2. This is on page 162 of the technical. Okay, so question 1. So like I always say, excuse me, what I say is always try and do the question yourself. So you pause the video and see if you're able to do it. And then after you're done, then you can play the video to see if what you did is correct. So the question says to sketch y is equal to minus 2x cubed plus 3x squared plus 12x by calculating the points of intersection with the axis as well as the coordinates of the various inflection and turning points. So remember what I said, there are 5 steps that you need to follow whenever you're sketching a graph of function. And if you follow those steps, you will always get the right curve. Now, step number 1 is you need to work out your intercepts. So your intercepts, your x-intercept, the y-intercept, these are where x is 0 and y is 0. So if we start with where x is equal to 0, so if x is equal to 0, then we have y is equal to negative 2 times 0 cubed plus 3 times 0 squared plus 12 times 0. And this leaves us with 0. So our y-intercept is the point 0, 0. And then we find the x-intercept. We know that the x-intercept y is equal to 0. So we have minus 2x cubed plus 3x squared plus 12x. This is equal to 0. Okay, and we can factorize this. First, we can divide everything by negative 1. So we have 2x cubed minus 3x squared minus 12x. This is 0. Then we take x out as a common factor. We have 2x squared minus 3x minus 12. This is equal to 0. Okay, so this one here, we cannot factorize it any further, so we'd have to solve it using the formula. So we say x is equal to 0, or 2x squared minus 3x minus 12 is equal to 0. And then using the formula to solve it, this is minus negative 3 plus minus the square root of minus 3 squared minus 4 times a times c, and we divide by 2 times a. So we get x is equal to negative 1.812, or x is equal to 3.312. Okay, so these are our 2 values here, and then you write down the coordinates of your intercepts. So the first one is when x is 0. We know that y is 0, so we have 0, 0. We have negative 1.812. comma 0. And then we also have 3.312, comma 0. So these are intercepts. That is step number 1. Okay. Then step number 2 is to find your turning points. Okay, so to find the turning points, you need to work out the first derivative. So we find dy dx. This, we know how to differentiate, is simple and straightforward. This 3 comes down, we have minus 6x squared. This one comes down, we have 6x plus 12. And know that at the turning points, the first derivative is equal to 0. Okay, so we equate the first derivative to 0, and we have minus 6x squared plus 6x plus 12 is equal to 0. If we divide everything by negative 6, we have x squared minus x minus 2. This is equal to 0. Okay, so we can factorize this. We'll put 2 numbers. When you multiply them, the answer is negative 2. When you add them, the answer is negative 1. So that is negative 2 and positive 1. We have x minus 2 is 0, or x plus 1 is 0. This means that x is 2, and here x is minus 1. Okay, now for each of these turning points, we need to work out the corresponding y value. So how do we work that out? We take, for example, this one, x is equal to 2, we substitute it there. We take x is equal to minus 1, we substitute it there, and then we will take corresponding y value. Okay, so if x is minus 1, then y is equal to minus 7. And if y is 2, then, sorry, if x is 2, then y is 20. So our turning points are 2, 20, and we have minus 1, minus 7. Okay, so that is step number 2, my turning points. Step number 1, intercepts. Make sure you are putting the points out like this. Putting out the points like this, so it's clear and it's easy for me to follow what you're doing. And then you found your intercepts and you are putting them there. I can see, oh, this is, you have your heading there at the top. Those are my turning points, and then you give me the coordinates of the turning point. Then the third step is the nature of the turning points. So what is the nature of these turning points? And what that means is, are my turning points maximum? Are they minimum? Are they points of inflection? Okay, so to determine the nature of the turning points, we have to find the second derivative. So we find d2y dx2, and the second derivative just means you must differentiate the first derivative. Here is our first derivative. We differentiate it, we get minus 12x plus 6. This is our second derivative. And each of these, we take the x coordinates, we substitute them in there, and then depending on what we have, then we will classify our turning point. So we find t2y dx2 when x is equal to 2. So if x is equal to 2, I have minus 12 times 2 plus 6 minus 12 times 2 is minus 24. Minus 24 plus 6 is minus 18. And then I state minus 18 is less than 0. So because this is what I'm using to determine the nature, it's less than 0. And that means that 2 and 20 is a maximum turning point. Okay, then I do the same thing for my other one. X2, then x is equal to -1. This is minus 12 times -1 plus 6. This is positive 12 plus 6. This gives me 18. 18 is greater than 0. And because it's greater than 0, this means that the turning point -1 -7 is a minimum turning point. So again, these are all the things that I want to see, that you've tested it in using the second derivative, and because of what you get, then you classify it. Then the fourth step, because we have found the nature of our turning points, and none of them is a point of inflection. The next thing is to actually work out what is our point of inflection. So we know that at the point of inflection, the second derivative is equal to 0. So we take our second derivative, we equate it to 0, solve for x, and then we'll solve for y. So we say minus 12x plus 6, this is equal to 0. So we have 12x is equal to 6. This means x is equal to a half. Okay, and if x is equal to a half, then we can work out the value of y as well. So if you remember, y is equal to -2, have a half to the power of 3 plus 3 times a half squared plus 12 times a half. Okay, and that means that our point of inflection is a half and 13/2. Okay, so those are the 4 steps that you must have done before you proceed to actually sketching the curve. Okay, and now we actually sketch it. So you draw your x and y axis, make sure they are clearly labeled. There's your x-axis, there is your y-axis. Then you start plotting your points. We have our intercepts. Our intercepts are here. We have the origin 0, 0, minus 1.8120, 3, 0.312, so you plot those ones. So you have one intercept here at minus 1.8. You have another one somewhere here at 3. Then you have another one over there. Okay, then our turning points, we have one at -1, -7, so that's somewhere here. And then we have another one at 2 and 20, so that's maybe somewhere there. And then after we've drawn, we will also indicate our point of inflection. So intersects, it's just passing through. Minimum, that maximum, like that, intercept going through, and you can see that the curve will go something like that. Okay, so the curve will go Okay. Try and go as smooth as possible. Yeah. To move this way. Keep those after. The curve will go like that. It'll continue there. Just trying to make it as neat as possible. Okay, that's better. Okay, so this point here, we say this is minus 1.812. Our minimum is at minus 1, minus 7. This is the origin. Our maximum over there, this is 2 and 20. And then here we have point. Zero. Okay, so that is our graph. Okay, so if you follow the steps, you will always get to the right answer. Okay. That was question 1 in the exercise. It's a good question. Question 2 says find all the critical points and sketch the curves of the following equations. So 2.1, we have y is equal to x squared plus x minus 12. So we follow the steps, our intercepts. Start with when x is 0. We have y is equal to 0 squared plus 0 minus 12. This means that y is equal to minus 12. So we have 0 and minus 12. And then we look at when y is 0. So y is 0, we have x squared plus x minus 12. 0. If we can factorize this one, we look for two numbers that when we multiply them, the answer is negative 12. And when we add them, the answer is positive 1. So that is 4 and negative 3. So this means that x plus 4 is 0, or x minus 3 is 0. This means x is equal to minus 4, or x is equal to 3. So our x-intercept will be minus 4, 0, and 3, 0. Okay, so those are intercepts. Next, we have the turning points. So to find the turning points, we find dy dx. dy dx, this is 2x plus 1. And we know that at the turning points, dy x is equal to 0. So we equate dy dx to 0, and we have 2x plus 1 is equal to 0. So 2x is equal to minus 1. This means x is equal to minus a half. And then we find the corresponding y value. We substitute x is equal to minus 1 there. So we have, so x is equal to minus a half. And we get minus 49 over 4. Okay, so we have only one turning point, and our turning point is minus a half minus 49 over 4. Okay, then we have to classify our turning point. Now with a parabola, it's easy because from the beginning, if you look at the coefficient of the x squared term, you can tell whether you have a maximum or a minimum. Here, because we have a positive number here, it means we have a minimum. So we expect that when we find the nature of our turning point, we should classify it as a minimum. Okay, so to find the nature, we work out our second derivative. This is the derivative of the first derivative, which is 2, and then we substitute when x is equal to minus a half. We are still going to get 2 because the second derivative is a constant, and this is greater than 0, and know that that means our turning point is minimum. Okay, so that confirms what we knew already. So if here, when you were working it out, you were not confirming that it is in fact a minimum, then you need to go back and look at your working and see, did I do something wrong? Okay, so that is the nature. And then you look for any points of inflection, if there are any. So points of inflection, this is when d2y dx2 is equal to 0. But we know that the second derivative is equal to 2, and it can never be equal to 0. That means we have no points of inflection. Okay, and remember what a point of inflection is. That's a point where the concavity of the graph changes. That means it goes from facing up to facing down, or the other way around. Now, if you think of a parabola, looks like this, it's always facing up for this one, or if it looks like that, it's always facing down. So it never changes where it's facing. And that makes sense to say that there are no points of inflection for a parabola. Then what we do is we sketch the graph. So that is the final step, our sketch. Our x-axis and the y-axis, which must always be clearly labeled. We have our points of intercept, our intersection points with the axis, with -4 here. And then we have 3 there. We have a minimum at -0.5, somewhere there, and then we have an intercept there as well. So I'll label those after. So it goes, reaches its minimum, and then cuts the graph like that. And then it goes on forever like that, and this side also forever. So this is the point at -4. This is the point 3. This point here, we worked it out. We said it's 0, -12, and our minimum, we have -1/2 and -49/4. Okay, and that is how you sketch it. Last thing is just to put y is equal to x squared plus x minus 12. Okay, so that is how you sketch it. Okay, so this one here, follow the steps. First, our intercepts. So we have when x is 0, this means that y is equal to 0. So we say 0, 0, 0. So our first intercept is the point 0, 0. And then when y is 0, we have x cubed minus 6x squared plus 9x is equal to 0. We factor out x, we have x squared minus 6x plus 9 is equal to 0. Continue factorizing. Factor this one. We have x minus 3 squared is equal to 0. So this means x is equal to 0, or x minus 3 is equal to 0, which means x is equal to 3. So our two intercepts are 0, 0, because x is 0 and y is 0, and x is 3 and y is 0. Those are our intercepts. Then next we have our turning points. So we find our first derivative. We differentiate. We have 3x squared minus 12x plus 9. And we know that at the turning points, dy dx is equal to 0. So this means that 3x squared minus 12x plus 9 is equal to 0. We can divide everything by 3. We have x squared minus 4x plus 3. This is 0. So we look for two numbers. When we multiply them, the answer is 3. We add them, the answer is minus 4. So that is minus 3 and minus 1. Okay, and this means x minus 3 is 0, or x minus 1 is 0. So this means that x is 3, or x is 1. And if x is 3, then if we substitute into the formula here, we get y is 0. And if x is 1, we substitute with 1 minus 6 times 1 plus 9, we get 4. Okay, so our turning points are 3, 0, and 1, 4. Okay, so the next thing is we need to classify these turning points. What is the nature of each of these turning points? Do we have a maximum? Do we have a minimum? Or do we have a point of inflection? Okay, to do that, we find the second derivative. Second derivative is just the derivative of our first derivative. So we take our first derivative and then we differentiate it. So when we differentiate, we have 6x minus 12. And then we substitute each of the turning points into the second derivative, and then depending on what we get, we classify it. This gives us -6. This is less than 0, and that means the point 1,4 is a maximum turning point. Then the second one is when x is equal to 3. So 18 minus 6. This is 18 minus 12, sorry, that's 6, which is greater than 0. So that means 3,0 is a minimum turning point. So it's very important that you don't just stop there and expect to guess what does that mean that it's less than 0. You have to specifically state it that it is a maximum or it is a minimum. Okay, so we've classified our turning points. Then the last thing is to check, do we have any points of inflection? Okay, so with our points of inflection, we know this is where the second derivative is equal to 0. So we equate the second derivative to 0. And this means that x is equal to 2. Okay, so if x is equal to 2, then we substitute and work out our corresponding y value. And we will get y is equal to 2. So this point 2, 2 is a point of inflection. Okay, so we've worked out everything we need. The last thing now is just to sketch the graph. Make sure your sketch is neat, it's proportional, and is easy to read. So x-axis and the y-axis must be clearly labeled. We have an intercept here, and we have one at 3, which is also a turning point, a minimum turning point. So it's like this, and then we have a maximum turning point over here. So you can see that our graph goes like that. It reaches the maximum, comes down to the minimum, intercepts, and then just bounces back. Okay, so this point here is 3. Just correct that a little bit. This point here is 1,4, and this is the graph of y is equal to x cubed minus 6x squared plus 9x. Okay, so that is our graph. Okay, then of course there is the point of inflection, which I shouldn't forget. That's it. Okay, the next question, this is the graph that we have to sketch. You can see it's another polynomial. So any polynomial that we're given, we should be able to sketch. Follow the steps, you will always get to the answer. So we start with our intercepts. when x is equal to 0. If x is equal to 0, we have y is equal to 0 to the power 4 minus 8 times 0 squared plus 16. This means that y is equal to 16. So we have 0 and 16. Okay, and then when y is equal to 0, we have x to the power 4 minus 8x squared plus 16. This is equal to 0. So this one here, you can factorize. If it's easier, then use a substitution. You can say let x squared equal to k. Do not let it equal to x. That would not be correct. Use a different letter. Then, of course, that would mean x to the power of 4 is equal to k squared. So what you actually have is k squared minus 8k plus 16 is equal to 0. And this is just k minus 4 squared is equal to 0. So k minus 4 is 0 and k is equal to 4. Okay, so if k is equal to 4, that means that x squared is equal to 4, and that means x is equal to plus or minus 2. So we have 2, 0, and negative 2, 0. These are my x-intercepts. Then I look for the turning points. So with the turning points, we have to find our first derivative. So we differentiate y, we have 4x cubed minus 16x plus 0. Okay, and then we know that at the turning point, the first derivative is equal to 0. So we equate 4x cubed minus 16x is equal to 0. You can see that 4x is a common factor, so we have x squared minus 1 is equal to 0. Sorry, minus 4. X squared minus 4 is equal to 0. And this means that 4x is equal to 0, or x squared minus 4 is equal to 0. So this means x is 0. This means x squared is equal to 4. So x is equal to plus or minus 2. Okay, so if x is 0, then this means that y, we substitute 0, 0 means y is 16. So our first turning point is 0, 16. And then if x is 2, substitute over there, we get y is 0. So our second turning point is 2, 0. And if x is negative 2, we substitute to get y is 0. So we have minus 2, 0 is our third turning point. Then the next step, number 3, is the nature of the turning points. Okay, so to find the nature, we work out our second derivative. And the second derivative is just the derivative of the first derivative. So when we differentiate 4x cubed minus 16x, we get 12x squared minus 16. Okay, and then for each of the turning points, we will classify them. Okay, so we start with when x is equal to 0. So if x is equal to 0, we have 12 times 0 squared minus 16. This gives us negative 16, which is less than 0. Okay, and that means 0 and 16 is a maximum. Okay, then second derivative when x is equal to 2. We have 12 times 2 squared minus 16. We get 32. This is greater than 0, so this means that 2, 0 is a minimum turning point. And then when x is equal to negative 2, we have 12 times negative 2 squared minus 16. This also gives us 32, which is positive, and that means minus 2, 0 is also a minimum turning point. Okay, so now we found the nature of our turning points, and then what we need to do is work out any points of inflection. So our points of inflection, these are when the second derivative is equal to 0. So we have 12x squared minus 16 is equal to 0. We divide everything by 4. We have 3x squared minus 4 is equal to 0. So x squared is equal to 4 over 3. And that means that x is equal to plus or minus the square root of 4 over 3. And this is plus or minus 2 over the square root of 3. Okay, so if x is equal to 2 over the square root of 3, then y is equal to 64 over 9. So we have 2 over the square root of 3, and we have 64 over 9. And then if x is negative, negative 2 over the square root of 3, then y is still 64 over 9. So we have minus 2 over the square root of 3, 4 over 9. Okay, so now we have everything we need. The last step, step number 5, is to actually sketch it. X and Y axis must be clearly labeled. We have our intercepts at minus 2, 0, 2, 0, and then we have 1 over here. This intercept is also a minimum. This one is also a minimum, and that one is a maximum. Goes like that, and from here it continues like that. Continues like that. This is minus 2. This is 2. This point here is 16. And then our point of inflection, we have 1 over here, which is minus 2 over the square root of 3 and 64 over 9. And this one here, which is 2 over the square root of 3 and 64 over 9. Okay, and then you label y is equal to x to the power of 4 minus So question 3 says, find the coordinates of the maximum and minimum turning points of each of the following. So we're not asked to sketch any of these ones. We just have to find the turning points and then obviously classify them. So what we need to do is find the second derivative. First derivative first. So when we differentiate this, the 3 comes down, so we'll have x squared, and then here the 2 will come down, minus x, and then we have minus 6 plus the 0. So we know that at the turning points, dy dx is equal to 0. So we have x squared minus x minus 6 is equal to 0. Then we factorize this. Look for two numbers. When we multiply them, the answer is negative 6. When we add them, the answer is negative 1. And that is x minus 3 and x plus 2. So this means x minus 3 is 0 or x minus 2 is 0. So x is equal to 3. Here x is equal to 2. And then for each of these, we need the corresponding y value. Okay, so to get the x value, we have the x coordinate, 3 minus okay, so when x is equal to 3, here we have minus 11 over 2. And when x is equal to 2, we have minus 10 over 3. So these are our turning points. We have 3 and minus 11 over 2, and 2 and minus 10 over 3. Now we need to classify them. We need to state, are they a maximum, minimum, or a point of inflection? So to do that, we find the second derivative. Second derivative is 2x minus 1. And then we have 90x2 when x is equal to 3. We have 2 times 3 minus 1. This is 6 minus 1. This is 5. 5 is greater than 0. And that would tell us that 3 and minus 11, 2 is a minimum. Okay, and then we do the same thing for the other one. When x is equal to 2, so we have 2 times 2 minus 1. Okay, I see what I did here. That was a mistake here. So this should be positive. So this should be minus 2. My bad. So I hope when you were working it out, you corrected it. So that would mean that the y coordinate is 46 over 3. Okay, substitute, and then here we get negative 5, which is less than 0, and that would be minus 2, and 46 over 3 is a maximum. So the question only asked for us to work out the maximum and the minimum turning point. So we don't need to work out the point of inflection if there are any. Okay, 3.2. Okay, so again, to find the turning point, the maximum and the minimum, we find the first derivative. We can use the product rule here. So we have 4x the way it is, and then the derivative of this one, the 2 will come down. At the top you have 1, and then you multiply by the derivative of the inside, which is -1. Or if you like, you can multiply out everything here and then work out the first derivative. In either case, you'll get the same thing. So this will be negative 8x multiplied by 6 minus x. All right, then we know that at the maximum and the minimum, the first derivative is equal to 0. So we have minus 8x, 6 minus x, this is equal to 0. So this means minus 8x is equal to 0, or 6 minus x is equal to 0. So here x is 0, and here x is equal to 6. Okay. I just realized I forgot to do the other part of the product rule. Okay, so here we have 4x, the derivative of this one, and then we have to add the derivative of 4x, which is x, and then the other one the way that it is. Okay, we can simplify. We have minus 8x, then we have plus x, 6 minus x, and we can see x and 6 minus x is a common factor. So we take that out. So we take x and 6 minus x out. We are left with minus 8 here. So when we multiply this, we get minus 8x, 6 minus x. Then here the x has gone up, and then we're left with a 1, 6 minus x. Okay, so this is x, 6 minus x. And here we have minus 8 minus 8 plus 6 is minus 2 minus 2 minus x. Okay, and then we can factor out the minus 2. So factor out the negative. Then we continue at the maximum and the minimum. The second derivative is the first derivative is 0. So we have minus x, 6 minus x, x plus 2. Okay, now I think it's correct, right? So again, let's see, using the product rule to differentiate, 4x remains the way it is. The derivative of this one, the 2 will come down. Then at the top you have 1 multiplied by the derivative of the inside, you get minus 1. And then here the derivative of 4x is 4, not x. And then the second one, the way it is. Then simplifying this one, we have 4x times 2 is 8x times minus 1 is minus 8x multiplied by x minus 6. And then this one remains as it is. And we can see that 4 is a common factor and 6 minus x is also a common factor. Then if we factorize, we're left with minus 2x. And here we have 6 minus x. Simplifying this, this is what? Okay. So we have 4 and 6 minus x. 6 minus 3x is equal to 0. And this means that 6 minus x is 0, or 6 minus 3x is 0. So x is equal to 6, or x is equal to 2.
Yeah, but my name is oh, there's nothing.
No. Okay. So if x is 6 or x is 2, we need to find the corresponding y value. So we take 6, we substitute it there, we will obviously get 0, and when we multiply, we get y is 0. And here, if y is 2, we have 4 times 2 is 8. And here 6 minus 2 is 4. 4 squared is 16. 16 times 8. We get 128. Okay, so our turning points, we have 6, 0, and 2 and 1, 28. Now we need to classify them. Are they minimums, maximums? What are they? But remember, the question is only asking for the minimum and the maximum. We're not interested in the point of inflection for this one. So we find our second derivative. So our first derivative is here. So first derivative, we can again use the product rule. Okay, let's do this one carefully. So we have this one the way it is. The derivative of this one is -3. Then we have this one the way it is, multiplied by the derivative of this one, which is -4. Because with the 4, I multiplied out, I have 24 minus 4x. Okay, so the derivative is -4. Excuse me. All right, so what does this give us? Negative, I can see 4, -4 is actually a common factor. So if I take that out, -4, then here I will have the 3 will still be there. So I have 3, 6 minus x, then the -4 went out. I have 6 minus 3x. Multiply out, this is 18 minus 3x. plus 6 minus 3x. Minus 4. 18 plus 6 is 24. This is minus 6x. So if you like, you can factor out 6. So you have minus 24. And we have 4 minus x. Okay, so that is our second derivative. And then we test. We start with when x is equal to 2. We have minus 24 and then 4 minus 2. Get minus 48. 0. That 2 and 8 is the maximum. Then we do the same thing. When x is equal to 6. And here we get positive 48, which is greater than 0. So we have 6. 0 is minimum. Okay. That is minimum. Okay. And that is how you solve that question. Then 3.3. Okay. So know that at the maximum or the minimum, our first derivative is equal to 0. So this differentiate, we get 0 here. We have minus 16x. And then we equate it to 0. So at the max or minimum, dy dx is equal to 0. So we have minus 16x plus 4x cubed. This is equal to 0. Okay, so we can see that x is a common factor, 4x actually. So 4x is a common factor. So if I write this one first, I will have x squared, and then I have minus 4. This is 0. So we have 4x is equal to 0, or x squared minus 4 is 0. This means x squared is equal to 4. X is equal to plus or minus 2. Okay, so here x is 0. Okay, so if x is 0, we substitute over there, we get y is equal to 12. So our first point is 0, 12. And then if x is negative 2, then we substitute in there, we get y is negative 4. So this is our second turning point. And then the last one, if x is 2, then y is also equal to -4, then our third turning point. Okay, and remember, we're only looking for maximum and minimum. So we find our second derivative. So we differentiate with -16 plus 12x squared, and then we substitute x is equal to 0. We get -16. This is less than 0. Okay, so if it's less than 0, this means that 0 and 12 is the maximum. Equal to -2 plus 12 is 2. And -14 less than 0. Squared is 32. Which is greater than 0. And therefore the point -2 -4 is a minimum. And then we do the same thing with the last point. Y dx2 when x is equal to 2. This is -16. 12 times 2 squared gives us 32, which is greater than 0. And 2 -4 is a minimum as well. Okay, so we found our maximum and minimum points. Then question 4 says find the minimum, maximum, and the points of inflection. Okay, so what you need to remember is that log base e of x is just ln of x. So this is actually just y is equal to 12 ln of x plus x squared minus 10x. Okay, then we are looking for our minimum, maximum point of inflection. We need to work out the first derivative. This is 12 over x plus 2x minus 10. And then we equate the first derivative to 0. So we find dy dx equal to 0. This means that 12 over x plus 2x minus 10 is equal to 0. So we can multiply everything by x. So we have 12 plus 2x squared minus 10x is equal to 0. Divide everything by 2. And I'm going to write this first. We have x squared minus 5x plus 6 is equal to 0. Then we factorize two numbers, we multiply them. We have positive 6, we add them, get negative 5. That is minus 3 minus 2. So x minus 3 is 0, or x minus 2 is 0. So x is equal to 3, or x is equal to 2. And then we find the corresponding y values. So we have 12, and then x plus x squared minus 10x. Okay, so if x is 3, then y is negative 7.817. And if x is 2, then y is negative 7.682. So these are our turning points. And now we need to find the second derivative so we can classify them. So d2y dx2, the derivative of this, remember, when x is in the denominator, it means the power is negative 1. So the negative 1 will come down. You have 12 over x squared plus 2. The derivative of that is 0 to y x2, and x is equal to 3. So if x is equal to 3, then we have minus 12 over 3 squared plus 2. This gives us 2 over 3. This is positive, and this means that the point right here, 3 and minus 7, this point here is a minimum. And for the second one, y dx2, when x is equal to 2, here we get negative 1, which is less than 0, and that means 2, 7.682 is a maximum. Okay, so with this particular question, it didn't just ask for the minimum or the max and the maximum. It said find the point of inflection as well. So at the point of inflection, the second derivative is equal to 0. So we have minus 12 over x squared plus 2 is equal to 0. We can multiply everything by x squared. So we have minus 12 plus 2 x squared is equal to 0. Divide everything by 2, minus 6 plus x squared is equal to 0. So x squared is equal to 6. That means x is equal to plus minus the square root of 6. And then we work out our y value. So if x is the square root of 6, we have negative 7.7. So the square root of 6, negative 7.4 is a point of inflection. And here we cannot take we cannot find the y value when x is equal to negative 6, because in our function we're taking logarithms. And with graphs, we are only interested in real values. So the logarithm of a negative number would not be real. So there's only one real point of inflection, and this is the one. Okay. If y is equal to 4x minus sine squared minus 4 sine x, prove that if the first derivative is 0 and cos x is 0, sine x is equal to minus 2/3, cos sine x is equal to half, and then prove that if x is an acute angle that is between 0 and 90, then y has a maximum value, and then we also have to determine this value of y. Okay, so first we have to find dy dx and equate it to 0. So dy dx, this is our solution. Dy dx, the derivative of 4 sine x, this is 4 cos x, and then the derivative of minus 4 sine cubed x, the 3 will come down, so you have minus 12 sine squared x, and then you multiply by the derivative of sine x, which is cos x. And okay, I skipped the minus sine squared x, but you can still write it there. Minus 2 will come down, and then you have sine x, and then the derivative of sine x is cos x. So this one was supposed to be in the middle before this one, but it doesn't actually change anything. Okay, so again, the derivative of 4 sine x is 4 cos x. The derivative of minus sine squared x is the minus 2 will come down, the sine x to the power of 1, and then on the inside you have the derivative of cos x of sine x, which is cos x, and then minus 4 sine cubed x, the 4 will come down and multiply, the 3 will come down, sorry, and multiply with the 4, you get minus 12. Then sine x to the power of 2, the derivative of sine x is cos x, using the chain rule. Okay, so then we say that if dy dx is equal to 0, this means that 4 cos x minus 12 sine squared x cos x minus 2 sine x cos x is equal to 0. So I can see here that cos x is a common factor, so I can take it out. Okay, then obviously what I have here is quadratic, so I can let y equal to sine x, and this means that y squared is equal to sine squared x. Then I substitute cos x, 4 minus 12y squared minus 2y equal to 0. Can divide everything by negative 2. So I will have cos x divided by negative 2. I'll get negative. I just want to write this one first. I'll have 6 y squared. Then divide this one by -2, I have positive y. And then divide this by -2, I get -2 is equal to 0. Okay, then we want to factorize this one. Look for two numbers, we multiply them. The answer is -12. And if we add them, the answer is 1. So that is 4 and -3. So we can factorize. Okay, so when you factorize, you have 4/6. 4/6 is 2/3. And then here we say we have 4 and so we have 2y minus 3. Minus 1. Okay, so we have 3 divided by 6. Okay, right, so can check if we multiply out, we have 6y squared, we have -2, this is -3 plus -3 plus 4, okay, right, it's fine. And this is equal to 0, and then we can work this out. So this means that cos x is 0, or 3y plus 2 is 0, or 2y minus 1 is 0. Here, this means that y is equal to -2/3, but remember that y is sine x, so sine x is equal to -2/3. And here y is equal to 1/2, which means that sine x is equal to 1/2. And that is exactly what we were trying to prove. Okay, and then the second part says prove that if x is acute, then y has a maximum value. So here we need to put what we know here into practice. So if x is acute, this means that x is between 0 and 90, okay? And because it's between 0 and 90, that's the first quadrant, then that means that sine x is greater than 0. Okay, so if sine x is positive, it's greater than 0, it means that this is the equation that we are supposed to take. We cannot take this one because here we will get x is equal to 90, and 90 is not acute, it's right. So we have to take this one. And here we can see that it's negative. So if sine is negative, that means it's the third quadrant or the fourth quadrant that is not acute. So the only one that satisfies x being acute is this equation. Okay, so we solve for x. This means that x is equal to sine inverse of 1/2. And this gives us 30 degrees. Or pi/3 radians. It's the work in radians, not that it changes anything. So it's pi/6 radians. Okay, and then we have to prove that this gives us the maximum y. So what we need to do, we already found the first derivative here. We found the first derivative, we equated it to 0, and we say that these are the critical points. And we picked this one specifically, and we want to show that this one specifically does give us the maximum. Okay, so we need to work out the second derivative. Okay, so our second derivative, we will use the product rule. So cos x the way it is. The derivative of this one, here we have 0, here the 2 will come down, so minus 24 sine x, then you multiply by the derivative of sine x, which is cos x, then we have minus 2 cos x, and then we add the derivative of cos x is negative sine x, so that is why the plus changes to a minus. Then the inside must just remain the way it is. Okay, so we can multiply out and then collect our like terms, just so substitution is a little easier. So if I multiply here, I have minus 24 sine x cos squared x minus 2 cos squared x minus 4 sine x positive 12 sine cubed x, and then positive 2 sine squared x. Okay, are there any terms that we can combine? Unfortunately not, so that means we just have to substitute. So d2y dx2 when x is equal to pi over 6. We have minus 24 sine of pi over 6 cos of cos squared pi over 6 minus 2 cos squared of pi over 6 minus 4 sine of pi over 6 plus 12 sine cubed of pi over 6 plus 2 of sine squared pi over 6. So remember, we want to show that this is a maximum. So if we've done it correctly, then our second derivative must be negative. Okay, so we'll work this out. We have minus 24 sine of pi over 6 is half cos of pi over 6 square root of 3 over 2. When we square that, we have 3 over 4. And then we have minus 2. Again here, cos of pi over 6 is the square root of 3 over 2. When we square that, we have 3 over 4. And then we have minus 4 sine of pi over 6 is a half plus 12. We have a half to the power of 3. That is 1/8. Then we have 2. And again, sine of pi over 6 is a half. And then we have a half squared. Okay, so we should work out, and hopefully we've done everything correctly and get a negative. Okay, so I'm getting negative 21 over 2, which is less than 0. And that means that we have a maximum. And then it said actually work out the maximum value. So if you remember the formula for y, we had y is equal to 4 sine x minus sine squared x minus 4 sine cubed x. So now we find y of pi over 6. This is 4 times sine of pi over 6 minus sine squared of pi over 6 minus 4 times sine cubed of pi over 6. So this is 4 times half minus squared 4 times a half to the power of 3. So what does this give us? This gives us 5 over 4. Okay, so it said determine the value of y. The value of y, the maximum value of y is 5 over 4. Question 6 says we have to find the coordinates of the inflection point, then find the gradient to the curve at this point, as well as the equation of the tangent to the curve at this point. So with our point of inflection, we know that at the point of inflection, dy, the second derivative rather, is equal to 0. So we find the first derivative. And then we find our second derivative. So 6x minus 12. And then we'll equate it to 0. We have 2y dx2 is equal to 0. This means that 6x minus 12 is 0. And that means x is equal to 2. Okay, so we need the y coordinate as well. So if x is 2, then y, just substitute there. X is equal to 8. Okay, so 2, 8 is a point of inflection. Right now, it's said find the gradient to the curve at this point. So what we need to do is find the gradient. Remember, the gradient is equal to the first derivative. So to work out the gradient, we find the first derivative dy dx, which we already did. This is 3x squared minus 12x plus 12, and we want the gradient at the point of inflection. So we take x is equal to 2 and substitute it. Dy dx is equal to 3 times 2 squared minus 12 times 2 plus 12. And this gives us 0. Okay, so if we have the gradient is 0, we know that means that we have a horizontal line. Okay. Then the last part, it says find the gradient of the curve at this point. So the gradient at the point of inflection is 0. And then it's a find the equation of the tangent. So the gradient of the tangent will be equal to the gradient at that point. So the gradient of tangent, this is equal to 0. And the equation must be y is equal to mx plus c. So we have our x coordinate is here it's 2, our y coordinate is 8, our gradient is 0, and now we solve for c. Okay. So our y coordinate is 8, our gradient is 0, x coordinate is 2, and c, so this means c is equal to 8. So then we write the equation of the tangent at the point of inflection is y is equal to 8. Question 7, determine whether f of x is equal to e to the power of x has a maximum or a minimum value, and then we have to find it. So what that means is we need our first derivative, f prime of x. We know how to differentiate this one using the quotient rule. So it is the denominator the way it is, multiplied by the derivative of the numerator. And then we subtract the derivative of the denominator, which is 1, minus the numerator the way it is. And this is all divided by the denominator squared. Okay, then we know that at the minimum or the maximum, f prime of x is equal to 0. So this means that x e to the power of x minus e to the power of x over x squared is equal to 0. That means x e to the power of x minus e to the power of x is equal to 0. So here, e to the power of x is a common factor. Take it out with x minus 1 is equal to 0. Right, then what we do is we solve this. This means e to the power of x is equal to 0. This has no solution. Or x minus 1 is equal to 0. So this means x is equal to 1. Okay, so if x is equal to 1, we can find the y coordinate. We substitute. We have e to the power of 1 over 1. So we have e. So our critical point is the point 1, comma e. And now what we need to do is we need to classify it. Is this a minimum or is it a maximum? So to do that, we find the second derivative. So we have f double prime of x. Here, we use the quotient rule again, the denominator the way it is, the derivative of the numerator, the derivative of this one here. We have to use the product rule. So derivative of x is 1 multiplied by e to the power of x. And then we add x multiplied by the derivative of e to the power of x, which is just x to the power of x. Okay, so that's the derivative of this one. And then you subtract the derivative of that one. So we have minus e to the power of x. So this is the denominator the way it is, and then the derivative of the numerator. So this is the derivative of this one, and this is the derivative of that one. And you can see that these two will cancel out. And then I subtract the numerator the way that it is. And then I divide by the numerator, the way it is, multiplied by the derivative of the denominator, which is 2x. And then divide by the denominator squared, which is x to the power of 4. Right. Then here these two cancel. So when I multiply out, I will have x to the power of 3, e to the power of x, and then here negative 2x squared, e to the power of x, negative will give me positive 2x e to the power of x, and this is all over x to the power of 4. Okay, then what we do is we can see that x here is a common factor and e to the power of x will, of course. So I take out x, e to the power of x. Here I'll be left with x squared. Here I'm left with minus 2x. Here I am left with 2. And this is over x to the power of 4. So x cancels there. I'm left with x cubed. And this leaves us with e to the power of x squared minus 2x plus 2 over x to the power of 3. Okay, then I'm going to substitute my x value, which is 1. So I find f double prime of 1. So I have e to the power of 1 multiplied by 1 squared minus 2 times 1 plus 2. And this is all 1 cubed. So you can see that these two cancel. And my answer is E. E is greater than 0. Therefore, the 0.1 E is minimum. Okay, for the last question, it says find the constants A and B so that y is equal to x cubed plus ax squared plus bx has a minimum value at x is equal to 4 and a point of inflection at x is equal to 1. So what we do is we find the derivative. So y prime, this is 3x squared plus 2ax plus. So we know that to find our minimum or the maximum, y prime must be equal to 0. So we say 3x squared plus 2ax plus b, this is equal to 0. So there isn't much we can do here to solve it, but it's important to take note of that. And then we are told, okay, it has a minimum value at x is equal to 4. So that means when we substitute x is equal to 4 in here into our first derivative, then we are going to get 0 because minimum values are critical points, and for critical points, the first derivative is 0. So we can say that since we have a minimum at x is equal to 4, then y prime of 4 is equal to 0. So when we substitute 4 into the first derivative, we should get 0. So if we do that, we will have 3 times 4 squared plus 2a times 4 plus b. This is equal to 0. So 4 squared is 16. 16 times 3 is 8 times 6, 48. and we have 8a plus b. This is 0. So we can write 8a plus b is equal to minus 48. So we can't solve for a and b with just that one, so we leave it for now. Then we move on to the second information we have. We're told that we have point of inflection when x is equal to 1. So to get our point of inflection, know that at the point of inflection, the second derivative is equal to 0. So we have to find the second derivative and then equate it to 0. So our second derivative, y double prime, this is 6x plus 2a, and the derivative of b will just be 0. Okay, so we know that y double prime at the point 1, because we're told that when x is equal to 1, we have a point of inflection. That means when we substitute 1 into the second derivative, we get 0. So this is 6 times 1 plus 2a. This is equal to 0. So 2a is equal to minus 6. So a is equal to negative 3. Okay, so if we have a is equal to negative 3, we can then substitute it over here and then work out the value of b. We have 8 times negative 3 plus b. This is equal to 48. Then minus 24 plus b is equal to 48. This means that b is equal to 48 plus 24. That gives us 72. Okay, and that is how you solve for a and b. So I hope you were pausing the video, trying the questions on your own, because like I say, practice really is the most important thing.